All right, good morning, guys. Today we're going to be reviewing linear functions. Hopefully yesterday you took your Unit 5, Section 3 test over graphing quadratic functions. If you have not done that, you need to go ahead and do that. You can still take it, it'll still be open. I remember you do have 2 attempts on that test, so if you only took it 1 time and you didn't get a good grade or a grade that you're not happy with, you can go ahead and take it again. All right, but today we're going to be talking about linear functions. You can find this sheet on the assignment. You need to go ahead and print it off, or if you want to, you can just copy it down on a separate sheet of paper. Either one is fine. So first off, just reviewing linear functions, we're going to start with what a linear function actually is. A linear function is a function that has a greatest degree of 1, all right, which means that the highest exponent in the problem is a 1. All right, so you're going to see like y equals 1x plus 2 or y equals 3x plus 1. That x has an exponent of 1. All right, its graph forms a straight line. All right, so that's going to be what goes in our blank here. It forms a straight line that has a constant slope, and then there is an addition pattern to linear functions because of the constant slope. All right, so basically you should be adding the same thing every single time when you look at a table, and whenever you're looking at a graph, it should form a straight line. Okay, so I've got a couple of graphs right here of linear functions. Very, very simple. It's just a straight line. If it starts from the bottom and it's working its way up, that is going to have a positive slope. And then if it's starting at the top and working its way down, that is a negative slope. All right, and remember that slope, you might want to write this off to the side, is equal to rise over run. Okay, and remember that we misspelled rise on purpose to remember that y goes on top. It's the change in y over the change in x. Okay, I always figure out what's my change in the y value and then what's my change in the x value goes on the bottom. All right, so that's what a graph of a linear function looks like. It's just a straight line. All right, if I'm looking at a table of values for a linear function, each table for a linear function has an addition pattern to it. We already wrote that down up at the top, but once again, it has an addition pattern to it. So as you're looking at a table of values right here, on the x side, I can tell that I'm adding 1 each time. All right. And then on the y side, I can tell that I'm adding 3. All right, so just like we said over here, it's my change in y over my change in x, which in the top table of values would be plus 3 over plus 1, which gives me a slope of 3. So this table has a slope of 3 over 1, which is equal to 3. All right, this linear function is an increasing function, all right, which means that it is going up, and then it has a y-intercept. This y-intercept is always when x equals 0. All right, so if I know that that's the case, then this point right here would be my y-intercept. So the y-intercept of this function would be at 0, 6. All right. So doing the same thing on the second table, once again on the x side, you're adding 1 each time, but then on the y side, now I'm subtracting 2, and that's my pattern. So this table has a slope of negative 2 over 1, which is just negative 2. All right, this linear function is a decreasing function. All right, it is a decreasing function because it's going down. It has a negative slope. And then the y-intercept here of this function, again, is when x equals 0. And so it, again, is going to be the same point, 0, 6. All right. Last but not least, if you're looking at an equation of a linear function, it's always going to be in the form y equals mx plus b. The main part of this problem here is that it's x to the first power. That goes back to what we initially said in this first sentence here, that a linear function has a greatest degree of 1. All right, if it's already in this form, it makes it pretty simple. So like on number 1 here, y equals 2x plus 1, That's in this form already. Y is a solve, it's on a side by itself. So I know that the slope is going to be 2 because my slope is going to be the m value. All right, so slope is m, and then b is my y-intercept. All right, so my y-intercept for this one would be 1. All right, on this problem here, you see that it's got x squared. If it has x squared, then it is not linear. All right, so it is not a linear function. Therefore, it has not a constant slope, and it will have a y-intercept, but we are not going to look at where that is on that one. Okay, we're just going to focus on the fact that it is not linear. All right, and then on the last problem, it does have x to the first, but it's not in slope-intercept form. So we want to go ahead and solve for y. All right, so 3x minus 2y equals 5. All right, if I try to solve for y, that means I need to move x over to the other side. So I got negative 2y equals negative 3x plus 5. All right, and then if I divide by negative 2, that means I have to divide everything by negative 2, and that's going to give us y by itself equals 3 over 2x, and then minus 5 over 2. All right, so our slope is going to be that number in front of x, 3 over 2, and then our y-intercept is this number right here, which is negative 5 over 2. All right, and these are points technically, so we want to put comma 0, and over here we also want to put comma 0. All right, those are the notes for today. You do have a short quiz that's on Canvas as your homework for tonight, so be sure that you do that. It shouldn't take you longer than 5 minutes. All right, if you have any questions, please let me know. You can message me on Canvas, or you can send me an email. You guys have a great Thursday. All right.